Hi, I'm Mike Lieberman, and I'm here to talk about SBOMs here. Um, let me start quickly, give you a little bit of sort of background of myself. I'm co-founder and CTO of Kasari. We do a bunch of stuff in the software supply chain security space, including SBOMs. We work a lot in regulated industries and things like that. I'm also a co-author of Securing the Software Supply Chain, which is a book that the QR code over there you can get a free copy for. I'm also heavily involved in open source in the sort of software bill of materials SBOM space as well, where I'm a technical advisory council member of the OpenSSF, and I'm also a governing board member of the OpenSSF. In addition, I'm a technical lead of tag security and compliance inside the CNCF, where we're doing also the same sorts of software bill of materials, supply chain security stuff for open source, but for cloud native. And I'm also a maintainer of various open source supply chain security projects, including Guac and Salsa. So let's get into it, right? So before saying like what's the bad, let's start with what's the good about SBOMs, right? And just to kind of like really pull back a little bit, what really are SBOMs, right? SBOMs are just an ecosystem agnostic way to describe software composition and metadata. A lot of times it's overblown. It can be, there's a lot of great things SBOMs can do, but I think that's kind of the primary goal, right? When folks say, hey, I already have a proprietary scan, I already have my requirements.txt, my package.json, why do I need a software bill of materials? Well, a software bill of materials just allows you to just describe what's in your requirements.txt, what's actually inside of your package in an agnostic way. So you don't have to go and say, well, you have to read my requirements.txt, you have to read my package.json. And if I have like a front end and back end application that are both Python and JavaScript, hey, you have to read both of those. It's like, no, here's just one document you can read. And then it's just also another thing is it's a standardized format, or rather, there's a couple of standardized formats around this, but generally they all follow the same sort of practices. And because of that, it makes it very easy for standardized tools to work with them. And in addition to that, even though I said, hey, there's two standardized formats for folks who are familiar, right? You have Cyclone DX and you have SPDX, right? There's a lot of controversy about the two of them having some infighting and that sort of stuff. But generally, I would much prefer two standardized formats over any n number of proprietary formats that only work with individual, an individual vendor's tools, which is always a huge problem in the space. Now, with that said, what are some bad things about SBOMs here, right? One of the things, and I'm sure a lot of you have been dealing with this, is like adoption is all over the place. Tooling isn't what it could be. A lot of tools support certain elements of SBOMs, but not everything. And there's different levels of support for the standards in the various tools, right? Some tools only support SPDX. Some tools only support Cyclone DX, that sort of thing. Some tools only support this set of languages. And hey, again, I think when it comes down to a lot of this, their usability is only good as the data you put into them. So if you don't have good data about your dependencies and those sorts of things, that's a huge problem. All right. So SBOMs are sort of still useful, even if you have one project, right? A lot of folks think that SBOMs are only usable when you have thousands upon thousands of packages and millions of different things kind of going on. That's not true, right? Even if you just have one project, SBOMs can be used to help you track your vulnerabilities, help discover license issues, and help just sort of understand dependency management in your project. A good example here is like, if for folks who remember the Log4Shell situation from like 2021, right? One of the big problems was, hey, am I using Log4j? I'm not directly including it, but am I including it because I've included Spring? right? That's a thing that you want to be able to answer because, hey, that's, if you're using this massively vulnerable piece of software, you need to know. And SBOMs help sort of glean that and help you understand that, even if you just have one project. So where can you get started, right? Start with simple tools and don't overcomplicate it. I think one of the biggest. Sorry about that. Where to start? So start with simple tools and don't overcomplicate it. One of the big issues that we have in the space is way too many people just assume that SBOM is this big gnarly beast of a thing, and it doesn't have to be. Yes, if you look at any of the standards regarding SBOMs, you have SBOMs that include fields for AI, SBOMs that include fields for stuff about hardware, about SaaS, all those different things. You don't need to start there, right? If in the future you want to get there, hey, that's great. But where can you get started, right? And the way you get started is, hey, just keep it simple, right? And that includes from generating SBOMs, where you can just sort of use a lot of various open source tools for that, but also just exploring the SBOMs you have. Do you need to have all sorts of complicated tools, including things like, I'm a maintainer of like Guac, right, where Guac can ingest lots and lots of SBOMs and provide a deep understanding of your supply chain. Is that where you need to get started? No, that's not where you need to get started. You could take a step back and just focus on simple stuff. And what does some of that simple stuff look like? Well, you will probably have a lot of this stuff already installed on your machines, right? Whether you're running on a laptop or you're running this inside of your CI/CD system like Jenkins or GitHub Actions or whatever, you probably have this stuff already installed, right? If you just want to kind of understand what are the tools inside of your, what are the components you're using for inside of your projects, if again, assuming you have the SBOM, you could just use JQ, right? Like most SBOMs nowadays are in JSON format. Yeah, some folks still use XML or whatever. And again, it's a sort of, your mileage may vary. You can swap out JQ for tools that are more focused on XML. You can write scripts in Python. You could use shell scripts. You could do all of these different things to then kind of just list the set of packages, right? That's an easy first step. And again, I think the thing that is really worth highlighting is way too many folks are just sort of leaving SBOMs in a shared directory somewhere, and they're not doing anything with it. And they're only using it purely for compliance, right? Yes, due to some the upcoming FDA requirements, or due to an executive order, or due to some other regulatory requirement, for example, the Cyber Resilience Act in Europe. Like there's this need, we need to have an SBOM. I need to distribute an SBOM, and I need to make sure that SBOM's accurate. Great, but that SBOM is also super useful, not just purely to check a box, right? It is useful because it helps you understand what is your software composition and what you can kind of glean from that, right? So now that you have this list of things, you might go in and say, okay, how do I now compare that to, what are the latest vulnerabilities? And so one of the things was I just yesterday pulled in the latest set of vulnerabilities that was on GitHub. And if you notice, all of that is from just that one day. And that's only the top, whatever it is, like 10 or so vulnerabilities, right? We could easily kind of extend this further where, hey, vulnerabilities are coming in day after day after day, right? Where there's way more than just 10 on the average day. And you might look at this and say, I don't use the Mattermost Confluence plugin. But are you sure? Right? You might say, hey, I don't use Tiny Scientist or any of these other things that are sort of listed here. But you might not use it directly, but you could be including it transitively, right? You might be including it as part of something, and it's included in a Docker image that you have on your machine and you didn't realize, right? And so these are all the things that are kind of coming in on a daily basis, and that SBOMs can help you sort of understand, right? Because now that you have data like lists of packages, you can compare it to the data from these vulnerabilities and say, okay, well, there's a thing called package URL, right? And I can compare the package URL that's in the SBOM to the package URL that is listed in the vulnerability, or CPE or similar sort of thing in whatever you might be using, right? And that's already, you could do that today with no specialized tools, right? Yes, it's gnarly. Yes, it's going to be a little annoying to kind of merge everything together and do that comparison, but you have that today. And then there's purpose-built tools, right? So you could write your own scripts or use or use like custom tools, write up your own stuff to kind of do that. And that's super useful, especially for certain organizations that the open source tools just won't work for. Again, I think some of the biggest challenges are going to be in spaces like, C and C++, where there's a lot more, there's a lot less, the use of package managers is not as prevalent in those sorts of things. But there's a ton of open source tools out there that can help sort of map those two things together. Just to kind of go back real quick, right? Again, is, hey, if I'm listing this set of packages and then I'm trying to compare it to these sorts of things, well, okay, all I want to do is just do that. Is there tools that can just do that for me? Yes. There's tools and that are in the open source space. And there's also a bunch of vendor tools as well, obviously. Like tools like OSV, tools like Trivy, tools like Gripe can kind of sort some of that out. And just to kind of give you an example here, right? You could run right now OSV scanner against an SBOM. And assuming, again, the SBOM has the right information in it, you can go in and actually pull out various different vulnerability metadata from there. So these are things like, in particular here, hey, I pulled down stuff from a particular SBOM, and I can see that I'm using the Babel runtime, and it is exposed to a particular vulnerability here that was discovered on, it was published originally on March 11th, and it had been updated with additional information on April 16th, right? And it has this GitHub service advisory ID, and then an alias to this CVE as well. And so you could do that today with your SBOMs, right? You can go, if you have one project and you're just like, hey, I just care about my one project, you could just run your SBOM you can run scans against your SBOM, right? You can run even stuff like, in this particular case, this was a NPM, this was an NPM project that you can run this against. You can run NPM SBOM, right? That's included inside the NPM tool. And you can do that today. And then, in addition to you have that one thing, right? You're like, okay, great. I'm running vulnerability scanning and that sort of stuff against one project. But you might have more projects. You maybe belong to a larger company. You are responsible for more things. Maybe you're a manager. Maybe you're a tech lead. You have a lot of different things. And one of the things here is you probably want to start tracking stuff, not just for one project, and also not just for one version of a project, but also across time and space, right? Hey, did I fix that vulnerability in the new release, or is it still there, right? Did I inadvertently, when adding some new dependency because somebody copy pasted something from Stack Overflow or copy pasted something from ChatGPT, did I include something new that maybe has some concerning elements? Like maybe it has a bad license, maybe it's malware. Like, how do I know those sorts of things, right? And then in addition to that, right, when I start to look at stuff, I might want to look at commonalities in the SBOMs, across my projects. Like, if I'm going back to that log4j example, do I have a vulnerable version of log4j in just my one project over here, or do I have it across all my projects, a subset of projects? Where does all of this live? Like, when the next time, again, a big issue happens, can I identify everywhere where these packages live, and these vulnerable packages live? And so you can do stuff again, like you don't necessarily need to start with specialized tools. You can start real quick with things like JQ, with things like diff, right? So here, again, this is, a bit of a simple example of I could throw this into a shell script, or, write a similar version of this in Python or whatever my scripting language might be, Perl, whatever it is, and be able to start comparing stuff in my SBOMs immediately, right? I can go in and essentially compare two lists of packages and say, hey, what's changed, right? And then again, if I'm using an actual scripting language, I can go in and do a little bit more and a little bit more, right? Where I can go in and say, great, am I using log4j? If so, what versions of log4j? And then I can again compare that to things in OSV, in these other tools, to sort of figure out what might be going on and to kind of be able to sort of compare again. Am I vulnerable to this one thing? Am I vulnerable to it in one place? Am I vulnerable to it across everything in my ecosystem? And so on. And so again, to kind of like reiterate here, most folks, you're dealing with more than one piece of software. You're saying, hey, I'm responsible for a bunch of different things. And in addition, even if you're only responsible for one project, in most cases, your project is not purely, it's just some JavaScript. It's not purely just, hey, this is a Go binary. It's usually, this is a Go binary that's running on this sort of VM or is running in this container image. And the great thing about SBOMs, again, is you can go and tie all of those things together to sort of understand what's kind of going on in your supply chain. And so if we kind of go to the next thing here, right? The sorts of things you're often trying to glean from all of this is, hey, you have your software up here. Often when you do sort of your basic vulnerability management, you're just looking at vulnerable dependency 2, right? You're just saying, hey, I directly import log4j, the vulnerable version of log4j. And you're kind of going in and saying, great, I have this vulnerable dependency. Cool, I can go and fix that, blah, blah. But that's usually not not usually, but this is just one example of something that's much broader, right? One of the bigger issues is the vulnerable dependency 5, right? Where dependency 1 looks fine. There's no CVEs about dependency 1, but dependency 1 pulls in vulnerable dependency 5. And then sometimes you're also not aware, and this is kind of a big issue with things like Dependabot and some of those other sorts of tools, is if vulnerable dependency 5 and vulnerable dependency 2 are technically the same dependency, right? They're both log4j. You go and you say, hey, great. I go and I take vulnerable dependency 2 and I like it's log4j and I update it in my manifest. And then you're like, why am I still, seemingly vulnerable to this thing? Or why am I still pulling in this vulnerable version of log4j? And then you have to go on a fishing expedition to kind of figure out what's kind of going on and yada yada. Whereas again, with SBOMs and these other tools that help enable SBOMs, you can actually then go in and say, hey, actually, we can see via the relationships in the SBOMs that you are pulling in not just log4j through the immediate dependency, but also through it transitively. And so now we can kind of go and say, great. So now that like I talked about how you can do some very basic things with some of these tools, right? I can use OSV for some of these things. I can use JQ. I can write custom scripts. This can be a little hard, to manage, right? It could be slow, right? I can go and throw all of that into a custom database, Postgres, DuckDB, whatever. That's, again, hard to scale. I have to manage it. It's a whole bunch. It's really difficult to keep track of results. There's a lot of custom code I'll have to manage. And there's other sort of solutions that are out there. Tools like Guac, which I'm a maintainer of, and we'll talk about in a second here. And there's other tools as well, like Dependency Track, right, which is an OWASP project that can also keep track of your SBOMs and provide you better insights into your supply chain over time and that sort of stuff. So let's go into Guac here. So what is Guac for folks who are not super familiar? Guac is observability for the software supply chain. So what does it do? Well, it's it's a database that sort of utilizes graph methodologies to sort of take supply chain stuff and turn it into a graph, which, as you can imagine, hey, if I have a supply chain, again, if I go back a couple of slides here, your supply chain is a tree type of graph. And then as you kind of combine a lot of these other things together, you can significantly more complicated graphs, right? And so Guac is a graph for your supply chain. And how does it do this? Well, it ingests supply chain security metadata like software bill of materials. But again, software bill of materials in and of themselves are just a description of the supply chain of your projects, and you need to enrich that data. Whether you enrich it in your SBOM or you enrich it through some other mechanism, you still need to pull from other sources to kind of get more information. Because again, even if you put in details in your SBOM, like this is vulnerable to this, we know this is vulnerable to this piece of to this vulnerability, that's only a point in time thing. Because again, vulnerabilities are discovered every day, and so over time, new vulnerabilities will be discovered, and that will obviously not be in your original SBOM. So you need to keep track of that data in something like a persistent database, something like Guac. And so what you can do again is you're pulling in software bill of materials and you're enriching it with data like data from deps.dev, which is an open source dependency database coming from Google, things like in Toto attestations, right? So things like Salsa for folks who are familiar with Salsa. And then if you have vulnerabilities, right, let's say you're pulling vulnerabilities in from OSV or a similar sort of data source, GitHub or whatever it may be. There's a lot of, for folks who are not super familiar, there's a term called VEX, the Vulnerability Exploitability Exchange, which is a way to sort of describe whether or not you actually are vulnerable to a particular vulnerability due to things like we don't use that code path. So even though the vulnerability is in a dependency, we have declared that we're actually not vulnerable to that, right? And then also additional metadata like OpenSSF scorecard, which can give you information about the health of your dependencies, and all sorts of other information you can kind of pull in there. Like clearly defined is another one, which helps you better understand license issues in your supply chain. Because for a lot of folks, I know this is a security conference, but for a lot of folks, security and compliance, especially license compliance, go hand in hand, because license risk is, even though it's not my customer's data gets leaked, that is still a huge risk for the organization, because the legal liability of misusing a dependency could be huge. And so again, just to kind of reiterate here, the goals for Guac is to aggregate and ingest supply chain metadata, correlate all that information, again, mostly software bill of materials, that sort of stuff, and then create a graph-based software supply chain data model. And so what does, again, this look like? I can't show a demo in real time, but for folks who are interested, you could feel free to go to guac.sh where you can learn more. But the sorts of things you can then do with all of this data that you're pulling in is you could do patch plans, right? You can go and say, hey, I know that I have this vulnerable package. And you can essentially go in and say, hey, what are all the things I need to do? And what do I need to update in order to fix this? And that's kind of where the end state of SBOMs is going, right? It's, hey, by keeping track of these SBOMs, which are records of all of this data, you can go in and use that to help say what needs to be fixed, what are like, if the next log4j was going to happen, what are the things we're most worried about? Oh, hey, we use this OpenTelemetry library everywhere, so we need to make sure that we're ready to update that OpenTelemetry library, right? If some library all of a sudden is, hey, they've deprecated it, the person who maintains that library has retired, they've given it up, they've abandoned the project. Great. What do we need to update, right, before this becomes an issue? This is huge. And then again, what are the sort of outcomes that kind of come out of using tools like Guac, using tools like Dependency Track, and some of the vendor tools, right? Like, that are out there, like whether it's Kusari or somebody else's, is, hey, the whole point of this is to aggregate data from hundreds of thousands of documents, right? Because you're most likely pulling in multiple SBOMs across one project, and then multiple projects across multiple projects. So you really are collecting all sorts of data over time. So data will build up on top of it, of other data, where you'll be able to track over time how things go. And then you want to be able to answer the sort of big and complex questions about your supply chain based on all that data. So where does this vulnerability live? Is it because of a transitive dependency? Is it exist in one place, in 100 places? And then I think one of the most important things is, what might I be missing, right? Like if I have a ton of data about these 5 projects, but the 6th project shows that there seems to be 1 or 2 dependencies, is that accurate, or is there something weird going on, right? It helps me understand where I need to kind of dive in. And then there's all sorts of other tools out there that can help as part of the SBOM journey, right? Pulling in inventory data about the systems like that you have, things like OS query, kubectl, obviously, K9s, all that good stuff. There's various other security tools that are focused on, for example, cloud native, but like Kubescape, but also just generally that can help organize your repos and better understand information about your project layout and stuff like that. For example, there's a tool called Scalibur. Integrating all of the stuff with SBOMs as part of your CI process is also hugely important, right? Jenkins and Tecton, right? Like your CI system or GitHub Actions or whatever it may be. Hey, did I fix the new vulnerability in the new build? You can go and quickly correlate the data that you have from something like OSV with something like Guac or, another vendor tool or whatever it may be, and say, hey, these are the vulnerabilities that exist in the new thing. And then here's the vulnerabilities that we already know about, right? You might say, hey, look, I only have to fix this after 90 days. And we recognize that this is a weird vulnerability that's going to take us a little while to pull out. But when you're actually deploying something, you want to check, is this a net new vulnerability I introduced, or is this something that we already know about, right? And it's really hard to do that if you're not keeping track of the data through stuff like SBOMs. And then finally, when you're about to deploy a thing, you want to be able to check, like, hey, I do not deploy anything with a known critical vulnerability, regardless of anything else, right? And you can start to kind of correlate that data from your software bill of materials with the vulnerability metadata, and then introduce them into deployment tools via via policy systems, whether it's OPA or Keyverno or built-in configuration inside of Flux and Argo. There's all sorts of mechanisms you can have there. And then finally, I'll kind of end with what are some of the challenges in all of this. So SBOM quality differs wildly. Some include transitive dependencies, others don't. And then sometimes that is due to a flag in a particular tool. Sometimes different tools do that, right? So it could be quite complicated. And then similarly, SBOM standards, hey, they keep adding new features as core elements. And this is something that, as somebody who builds tools in this space, not so much on the SBOM creation side, but on the SBOM consumption and management side, it's hard to keep tools up to date when there seems to be a new feature in SPDX and CycloneDX coming out every day, especially when, even though those things are listed as manual or they're listed as optional, when you're building tools, often they can't be optional because everybody wants different things. So anyway, so there's a lot you could do with SBOMs. And I think, again, super important to start using them And again, you can get started real easy. You don't need a whole bunch of custom stuff, but over time, it's probably worthwhile to look at some of these other more comprehensive tools. Thank you.